Okay, so yeah, this question is terrible, but I think the real problem is the way they list the answer because they only listed one possible answer, I think. When you click the solution box, I believe it'll accept a series of answers, at least it should. So I think zeros do count. So if I were to look at this, I'd say, okay, the first and last digits must be odd. So that means the A and D must be 1, 3, 5, 7, or 9. So as of right now, there are 5 choices for the first number, 5 choices for the last number. Now I'm going to adjust that accordingly, obviously. And the second digit cannot be a 4. So there are normally 10 values. There's 0 through 9. So there's 9 possibilities left for the second digit because it can't be 4. And digits cannot be used more than once. So to determine the total number of possible banknotes. So I go off the first option here. So I'd say, all right, there are 5 choices for this first number. I think that's going to stay a 5. Now, the second number can't be a 4, and it can't be the number previously picked from this guy. So let's say we picked the 3 here. So this number can't be a 4, and it can't be a 3. So there are 8 possibilities left. Okay. This number has no restrictions on it, except that it can't be this number and it can't be this number. So this is going to be 8 as well. And the last number has to be different than the previous 3, and it has to be odd. Now, here's the weird one. It can be 1, 3, 5, 7, or 9, but it can't be any of the. So here's the weird part. So when you're trying to find the number of possibilities for this last digit, we don't know if, let me just put a possible selection underneath these. So let's say the first number was a 3. This number can't be 3 or 4. So let's say this number is a 6. This number can't be 3, 4, 6. Let's say this number is a 2. Now, when I try and figure out the number of possibilities for this last value, the problem arises that these 2 middle numbers could be odd, in which case this goes down. Okay. Or these 2 could be even like they are here, in which case this does not go down because this can only be odd, right? So the way I have it written right now, there are 4 possibilities for this number because it has to be one of these and it can't be 3 because we already used 3. But there's an issue here because I don't know if these middle 2 numbers are odd or even. So the way around that is to pick these middle 2 numbers last. Okay. So I pick the 3 here. This last number can be any of the other odd numbers, but it can't be 3. So there are 4 choices left that this last number can be. Now let's say this number is 7. Come on, stupid. Oh, this is stupid. So then that means this second number here can be any number except 4, and it can't be 3, and it can't be 7. So that's 10 minus 3, that's 7 options. This number here can't be 3, can't be 4, can't be whatever this is. Let's say this is 2. So this has 7 options. So that's where the computer comes up with this 5774 answer. But it is a very, very tricky question. And usually in the past, since I felt like this was a little unfair to students, if this pops up on the problem set of the exam, I will give you credit back for this question.